we'll be treating questions on the Newton's law only, and I believe that each and every teaching should later then treat questions. So if you're watching this lesson for the first time, there is lesson 1 and lesson 2, which are focused on teaching and explaining concept. Then this one is focused on treating exam questions, because I believe that treating exam questions is not to teach, but is to apply what you would have taught initially. So please check lesson 1 and 2, and don't forget, if you haven't subscribed to the channel, make sure that you press the subscribe button. Also press the notification button. Also tell someone about this channel, tell your friend. This lesson is for grade 12 and grade 11. If you are in grade 12, surely refer someone to this channel, because this channel is doing wonders. This channel is assisting kids. This channel is really useful. We are going to start from question number 8. We'll do question number 8. We're using a document that is called the last push, because now we're in the last push. Today is Thursday and tomorrow is Friday. The grade 12s 2023 are writing paper 1 for mathematics. Next week Friday, they're writing paper 1 for physical sciences. So we're in the last push, we're preparing. We're using a document that is called the last push, which is a compilation of previous question papers. So here we have Newton's law, question number 2 question papers, which are compiled into one document. So we'll be treating all those questions. Question number 8. Question number 8, it is appearing now on your screen. Question number 8 reads as: a crate of mass 2 kg is being pulled to the right across a rough horizontal surface by a constant force F. The force F is applied at an angle of 20 degrees to the horizontal as shown in the diagram. Okay, so we have a crate which is on the surface, a crate of 2 kg. Then there is a force that is applied at an angle of 20 degrees. We are not given the magnitude of the force, and that is force F. So the question is like that. The first question, it says that draw a level free body diagram showing all the forces acting on the crate. The crate of mass 2 kg being pulled to the right across a rough horizontal surface by a constant force F. Okay, let us draw a free body diagram. We know that there are 4 forces that are going to act: frictional force, applied force, as you can see, is force F, normal force, and gravitational force. Normal force is going to act because this object is on the surface. Remember, normal force is a force that the surface exerts on an object it is in contact with. The only time when normal force does not act is when an object does not have a surface, is moving in the air. Okay, so let us start. How do you know that there is frictional force? It's because the statement says that an object is moving on a rough surface. Rough surface means there is friction. Smooth surface means there is no friction. So the free body diagram of this one will be: we draw a body, then we draw, this is a body, then we have normal force which is pointing up, then we have gravitational force, then the friction is parallel to the surface. Friction is a force that opposes the motion of an object and acts parallel to the surface. Then you can see that the applied force there is acting at a particular angle. So we're going to represent it the way it is there. You can write FA, or you can write F like that, since we're told that that is force F. Or you can write FA if you want, or it will be correct for representing it as F or FA. So this is the free body diagram for the question that appeared on your screen. Let us go to the second question. The second question, it says that a constant frictional force of 3 Newton acts between the surface and the crate. The coefficient of the kinetic frictional force between the crate and the surface is 0,2. Calculate the magnitude of the 8.1.2 normal force acting on the crate. Now they need us to calculate the normal force that is acting on the crate. In lesson number 2 for Newton's law, you can check it. When we calculate the normal force, which we represent by N, we focus on forces that are acting vertical. Focus on forces that are acting vertical. What are those forces that are acting vertical? The first one is normal force, the second one is gravitational force, the third one, it is going to be the component of force F. The component of force F. But because we do not have the magnitude of force F, it means we won't be able to get or calculate the component of force F. Remember, force F have got 2 components according to lesson 1 and 2. Check them if you haven't checked them so that you have a full understanding. We can resolve this force into a vertical component and a horizontal component. Horizontal component, which is called Fx, it is resolved as force, this force, cos theta. Theta is this angle. Cos y is force, sine theta. So that's how we resolve this force. So we're going to have another force which will face up, then the other force will be like this. The Fx is like this, the Fy is facing up, just like that. It's a vector. Okay, so this way of using the method of resolving into components, it will not work because we are not given the magnitude of F. But the most interesting thing is that we are given the friction and we are given the coefficient of that kinetic friction. So we're just going to use a formula that is called Fk kinetic formula. Kinetic friction is equals to N multiplied by Uk. This N does not stand for Newton, it stands for normal force. This N stands for normal force. Then, when given the kinetic friction, it is 3. Then normal force, multiply it by the coefficient of kinetic friction, which is 0,2. Then it means if we want to get the normal force, we'll just say 0,2. We divide by it on both sides. Then the normal force is equals to, normal force will be equals to 3 divided by 0,2. 3 divided by 0,2, that will be 15 Newton. So it means we have 15 Newton up. 15 Newton up. That is the magnitude of our normal force. Okay, let us move further to the next question. The next question, 8.1.3, it states that calculate force F. It states that we need to calculate force F. So now the question is, how do we calculate force F? There are many methods which we can use to calculate force F. Okay, let us start to calculate force F. Let me erase this so that we can understand. Since now we have the normal force which is equals to 15. Normal force is equals to 15, whereby we divided 3 by 0,2. We got 15. So it means that if we want to calculate the force F, we know that normal force is what for this object? If you check the very introduction of lesson number 2, I gave you different scenario whereby there is an applied force applied on at an angle, where there is no applied force, where the applied force is going downwards. Yes. So check that. So if we want to calculate normal force for this one, I'm going to say normal force is equal to gravitational force. Since it is the one of the forces which are acting vertical, then we're going to say gravitational force. Then we check which other force is vertical. It is the F, the component of this force F. It is the Fy. And in which direction is the Fy going? Fy is going up. How do we know that? Whenever we have the applied force going up, its component, the vertical one, will also be going up. So because this F is going up, even its Y component will be going up. So it means that the Fy is going up, Fg is going down. So when vectors are going to different directions, what do? We subtract them. So it means we're going to say Fg minus Fy. Can you see? We're subtracting because Fy is going up, Fg is going down. How do we know that Fy is going up? It's because the force F, isn't it? Fy is the component of force F. So force F is going up. It means its vertical component will be going up. If force F was going down, its vertical component was going to be going down, and we're going to add it with the gravitational force because they will be both going down. You understand? So it means normal force is going to be equal to mg minus F sine theta. Do we have normal force? Yes, we have 15. Then the mass is 2 kg, 9,8 minus F. We don't know force F. Then we have sine 20. Then what do we do here? We're going to have 15. We subtract 2 multiplied by 9,8. 2 multiplied by 9,8 and we get 19,6, which will be equal to minus F sine 20. Then 15, we subtract 19,6, 15 minus 19,6, that will give us minus 4,6. So we have minus 4,6, which is equal to minus F sine 20. So if we want to get the value of F, we're going to divide by minus sine 20 minus sine 20. Then F is going to give us minus 4,6 divided by minus sine 20. Minus 4,6 divided by minus sine 20. And that is going to give us 13,445 newtons. Newtons up. It is going up. The direction. It is going up. So it means that the applied force in this object is 13,445 Newton up. So that's how we can calculate the force. That's how we can calculate the what? The force F, which is the applied force. Okay, let us move forward, ladies and gentlemen, to the following question. The following question says, calculate the acceleration of the crate. Calculate the acceleration of the crate. So we need to now calculate the acceleration of the crate. Let me use this space. Let me use this space. Let me use this space. If we want to calculate the acceleration, we know there is a formula. There is a formula which says that F net is equal to ma. So we need to calculate this a, which is the acceleration. Now we can check the F net. Remember, F net is the sum of all forces that are parallel to the surface, forces that are horizontal. So we may check forces that are parallel to the surface. We may check forces that are horizontal. So let us check. What are those forces? The first force that I know is frictional force. We know that frictional force is going to act in this direction. Rather, let me write it here. F net is equal to ma. So checking here, F net is the sum of all the forces that are horizontal. All the time, we check only forces that are horizontal to the surface, forces which act in this direction to the surface. You understand? Only forces that are like this, that is F net. So the first force is frictional force, because frictional force will be going in this direction. Frictional force will be going in that direction. The second force is what? The second force is the x component of this force F. You can see that force F is not moving like this. It is moving like this at a particular angle. So F net is the sum of all forces which are horizontal, which are parallel to the surface. So this force F is not parallel to the surface. We will not use it. The only force that we are going to use is the component of this force F. Remember, I was demonstrating to you that this force F has got the two components. It has got the vertical component, which is Fy, which is calculated as force F sine theta. This force F also has a second component, which is called Fx. So how do we calculate that Fx? Fx is equals to force F cos theta. Theta is the angle between the surface and the force F. Can you see that? So it means that the forces that are parallel to the surface, that are acting horizontally, it is only two forces. That is what? A frictional force and the Fx, which is the component of F. You understand? But they are moving in this direction. Since the object is moving in that direction, the object is moving in that direction. It means that the force, frictional force is moving in this direction. So Fx, the component of the force F, is moving in that direction. Frictional force is moving in the other end, meaning that these two forces are going to have two different signs. So it means we're going to have minus frictional force. Can write Fk if you want, minus frictional force, then plus Fx is equals to Ma. You understand? Why did we write these two forces? Because F net is the sum of the forces which are acting parallel to the surface or horizontal. You understand? So what is the magnitude of the frictional? It is 3 newtons. Then it is 3 newtons. Then how do you get, before I write, just write the formula here so that you can understand. Fx, how do you calculate Fx? We say force F, we multiply it by cos theta, then we have Ma, and let us substitute. What is the magnitude of force F? The magnitude of force F is minus 3 plus force F. We just calculated force F, we got 13,45. Then we have cos 20 is equals to mass is 2a. Remember, we are trying to calculate for what? We are trying to calculate the acceleration. So let us add this. What will we get? Minus 3 plus 13, 445. What do we get? We get 10,45, which is equals to 2a. If you want to get the acceleration, we divide by 2, and the acceleration is 10,45 divided by 2, and that will give us 5,225 meters per second square. To the right. We must not forget to write the SI unit and the direction, because acceleration is a vector quantity. So yes, we got the acceleration now. We got the acceleration. So that's how we calculate the acceleration. Check lesson number 2 towards the end. I'm teaching about F net is equal to Ma. F net is the sum of all the forces that are horizontal, that are parallel to the surface only. We don't add any other force. Even when a force is acting like this, we cannot add it. When a force is acting like that, we cannot add it. We only add forces which are acting horizontal to F net. That's what F net means. Let us check if we have another question. We still do have. Okay. Oh, we no longer have. We no longer have, because the remaining question, it is dealing with universal law of gravitational force, which is not something that we are treating at the moment. Okay, so it means with question number 8, we are done. We can go to question number 10. Question number 10, it is on an incline. Question number 10, it is on an incline. So basically, we are done with it. We are done with question number 7. Go to question number 10 this time around. And we solve question number 10. Okay. So these Newton's law are not difficult. They're easy. All you need to do is to master the rules. Okay. Question number 10. Notice that these are previous question papers for the past 3 years, 2015, 2017, 2018. I'm just using a document that is called Last Push. It is a very good document which you can use to study with. If you haven't subscribed, please make sure that you hit the subscribe button. Support this channel, because this channel is making physics easier for many kids. So please make sure that you subscribe to this channel. As you can see, that the content of this channel is very useful. Refer the grade levels, since some of you will believe me. Refer the grade levels to this channel. Okay, now we're in question number 10. Question 10, it reads as it is appearing on your screen. An 8 kg block is being pulled by a constant force F up a rough incline plane at an angle of 80 degrees to the horizontal at a constant speed. Force F is parallel to the inclined plane as shown in the diagram. State Newton's first law in words. Draw an every body diagram for the block. Okay, let us start with those questions. We are told that the force F is pulling a block which is 8 kg. A block which is 8 kg. So check now that the force is acting like this. But this force is parallel to the surface. For the first one, the force was acting like this, yet the surface was flat. You understand? So now the frame of reference have changed. It means force F, we can use it for F net because it is parallel to the surface. Because the surface now, the surface is like this, and the force is acting like this. It means for F net, we can use that force F. I'm trying to clear the confusion about that. Because now the surface is like this. It means each and every force which will act in the same direction as the surface, we can use it for F net. Okay. So the first question says that it gives us Newton's first law. Newton's first law, you can read it for yourself. It says that an object will remain in the state of rest or uniform motion unless an unbalanced resultant force acts on it. So that's what Newton's first law states. You can read it using your own exam guideline so that you do not omit any key word. Okay. Draw a free body diagram for that. So I'm interested on the drawing the free body diagram. The free body diagram is that. Okay. We know that there is frictional force here. How do we know? It's because we are told that it's a rough surface. The way the rough surface, it means that there is a frictional force. You don't assume that when an object is moving on a particular surface, there is friction. You will be told, there will be clues, there will be certain ways that will be telling you that there is frictional force. So the free body diagram for this one, it is going to be a body. We have a body. then the object is going up. By applying force or force F, there is friction, which is F or Fk. Then gravitational force is a line which is pointing down, which will be gravitational force. Then normal force is a force that the surface exerts, and it acts perpendicular to the surface. So normal force must be what? Must point that direction. Normal force must point that direction. Why is normal force pointing that direction? So that we can have a what? A 90 degrees in the surface. So you must not write this myself, I'm just demonstrating to you. So that is our free body diagram. So the surface is like this, meaning that all the forces which are moving like that are part of F net. As F net, we use forces that are moving horizontal to the surface, that are horizontal to the surface. So it means if the surface is like this, the frame of reference is, we will use forces that are moving like that are parallel to the surface. Okay. Then let us go to the second part of this questions. We are told that the kinetic frictional force between the block and the surface of the inclined plane is 20,37. Fk is 20,37 Newton. Then calculate the magnitude of force F. Calculate the magnitude of force F. So now we are being requested to calculate the magnitude of force F, which is very interesting. So how do we calculate force F? If we want to calculate force F, it is straightforward. We use a formula that is called F net is equals to MA. F net is equals to MA. And we notice that we are told that the object is moving at constant speed. I told you in lesson number 2 that the word constant speed, it means that acceleration is equals to 0. Constant speed, it means the speed is not changing. Yet acceleration means the change in speed. So it means that the acceleration is 0. So since that object is moving at a constant speed, it means that F net is equals to 0. It means that F net is equals to 0. Then we can calculate force F. How do you calculate force F? Remember, F net is all the forces that are parallel to the surface. F net is the sum of all the forces that are parallel to the surface. F net is the sum of all the forces that are parallel to the surface. So, what are the forces that are parallel? By parallel, it means this time we focus on forces that are moving like this. Why are we focusing on forces that are moving like this? It's because the surface is like this. So F net is forces that are horizontal to the surface as a frame of reference. We focus on forces that are parallel to the surface. So what are those forces? Frictional force will be there because frictional force will point down in this direction. Applying force, you see that the applied force is not at any angle. It is parallel to the surface, it will end. Right? The last force, which you can see here, it is FG parallel. Check lesson number 2. FG parallel. Remember that we're going to have gravitational force, which will be pointing down like this. So as this force is the gravitational force is pointing down. Gravitational force is pointing down. Normal force will point in this direction. Right? So here we'll have FG perpendicular. Then we'll have FG parallel. FG parallel. So since this object is on an incline, one of the forces that is acting parallel, it is what? FG parallel. We must never forget that. because F net is all the forces that are horizontal or parallel to the surface. So let us start to deal with this one. It means that F net will be equal to frictional force. Frictional force is downward. The second force, which other force is downward, is going to be minus Fg parallel. Why am I saying Fg is downward? Remember, gravitational force is always what? Downward. This object is going up. Friction will be pulling an object down. Gravitational force is always downward. We will also be pulling the object down. So that's why all of them must have signs that are negative. Then there is only one force which is going up, and that is applied force. All of them, their sum is equal to 0. So we can start now. So frictional force was given. We are given that the frictional force is minus 20.37 Newton. Then the gravitational force, if you write it on the side, Fg parallel, there is a formula which I showed you in lesson 1 and in lesson 2. In lesson 1 towards the end, in lesson 2 in the introduction of the lesson in the beginning. So we're going to have Fg parallel is going to be force, since it's a component. Remember, a component you say force trig ratio theta. So we're going to have force, then since it is parallel, it means we are going to use sine theta. I also even explain why I'm using sine for the component of gravity. So then here it means we are going to have minus, here we put 9.8 sine. What is the theta for that question that we are treating? Is 30. There's a 30 here. So that is 30. So it means Fg parallel is equals to what? We punch that. We have 8 multiplied by 9.8 sine 80. So that's what we have. We have 39.2. So it means we have 39.2. 39.2, that is our Fg parallel. So we're going to have 39.2. 39.2 plus applied force, which is equals to 0. So what does that mean? It means that the applied force will just add these two and we make them cross to the other side. So it means applied force is equals to, we add this one. We have minus 20.37 minus 39.2. Then that is going to give us 59.57. I just added them, guys, then I made them jump to this side. That's why we have a positive answer. So it is going to be 59.57 newtons up. Don't forget the what? The direction, since there are marks for writing the magnitude and the direction. So that's how we calculate the applied force for that one. It is not difficult. It is easy. It just needs you to understand what is happening. If you watch lesson 1 and 2, I guarantee you that you will be understanding Newton's law by the end of watching those videos. Ladies and gentlemen, let us continue with our questions. We now we calculated force F. We are told that force F is now removed and the block accelerates down the plane. The kinetic frictional force remains 20. So this time around, we removed force F. Force F is removed. So since force F is removed, the object starts to move down. Friction did not change. It means friction has changed direction. Friction is now acting in this direction. You understand? So the object is now moving down. That's what the question says. Then, what do we do? It is appearing on your screen. What do we do now? It says that calculate the magnitude of the acceleration of the block. Calculate the magnitude of the acceleration of the block. Now, that force F, it was removed. Force F was removed. Then the object started to move down. So as the object was moving down, they need us to calculate the magnitude of the acceleration. Because now the object is no longer moving at constant velocity. It is no longer moving at constant velocity because the constant force was removed. So now, let us calculate the acceleration in that scenario. It's a scenario where there is no applied force. It's a scenario where there is no applied force. So we can still use the very same formula of F net is equals to MA, because it's the only formula in this case which can work that has the acceleration. Continuum of motion cannot work. So since we are told that force F was removed, the applied force was removed, and the object began to move backwards, we check how many forces that are horizontal that are acting there. What are the forces that are horizontal to the surface or parallel to the surface that are acting? The first force that will be acting, it will be frictional force. The second force that will be acting, it will be mg parallel, then ma. There's no other force which will be acting horizontally when this object is moving down. Now, gravitational force is always downward. The object is moving down. Do you see that? Frictional force will be opposing the motion of direction of an object. It means frictional force will be going up while the object is going down. Meaning that the two forces are no longer moving in the same direction. So it means that this force FF is going to be minus and the FG is going to be positive. Are we together? So now we move forward. The frictional force, we were told it never changed. It remained being 20.37. Now we on the side, we can try to calculate the gravitational force parallel. Fg parallel, it has got a formula which is called, given by mg sine theta. Then the m is 8, g 9,8 sine 80. Sine 80. Then you get the answer for that one, and the answer will be 8 multiplied by 9,8 sine 80. Sine 80, 89,2, 89,2. It does not change. It's something that we already did. So it means the frictional force is going to be minus 20,37 plus 89,2, which is equals to 8A. Then it means we're going to subtract 89,2. It's not 392, it's 89,2. We're going to have minus 20,37, subtract 89,2, and get 18,83, which is equal to 8A. Then what do? We divide by 8. We divide by 8. Then our acceleration is going to be 18,83 divided by 8. We're going to have 18,83. We divide by 8. And we're going to get 2,35 meters per second squared. So our acceleration is 2,35 meters per second squared. So I want us to take a look at question number 13, which got the two boxes that are connected together. Question number 13, I've got two boxes that are connected together. And what I like about it is that there is downwards motion. Because I know that most of you learners, when you see object being like that and there is downward motion, you get to fear and think that you will not be able to solve it. So I want us to deal with that. Question number 13 is appearing on your screen. It says that a block of mass 8 kg is placed on a rough horizontal surface. The 8 kg block, which is connected to a 2 kg block by means of a light inextensible string passes over a light frictionless pulley. Start sliding from point A as shown. Let me read that. A block of mass 8 kg is placed on a rough horizontal surface. The 8 kg block, which is connected to a 2 kg block by means of a light inextensible string passing over a light frictionless pulley. It starts sliding from point A as shown. State Newton's second law in words. Newton's second law in words, you can read it for yourself, but it states that when a net force or a resultant force acts on an object, it will cause an object to accelerate in the direction of the resultant force with an acceleration that is directly proportional to the force and inversely proportional to the mass of an object. You can check that on the example line, and you don't omit weights. Don't despise definitions, they're very important, you need to know them. They contribute a lot of marks in an exam, so give yourself time to study definitions, then those definitions will assist you a lot. So let us go to a free body diagram. 13.2 says draw a level free body diagram for the 8 kg block. For the 8 kg block. What I notice is that there is frictional force for the 8 kg block. There is frictional force. How do I know that there is frictional force? It is because we are told that the surface is rough. Notice that I don't just assume that there is frictional force. I know that there is frictional force because we are told that the surface is rough. So rough surface means that there is frictional force. Okay, so now we can start to deal with the free body diagram for that one. So it means it is on a horizontal surface, the 8 kg block. So the free body diagram for the 8 kg block, we are going to draw a line, a straight line, then we draw the body, then we have normal force, and then we have gravitational force. We have a frictional force. Frictional force will be in this direction. Frictional force will be in this direction. Never use a free hand to draw a free body diagram. Just like what I'm doing. Don't just say by your hands. Use ruler. I cannot be able to use a ruler because I don't have a bigger ruler to assist me to draw this. So yourself, make sure that you use a what? A ruler, so that you don't get penalized. Then we know that there is a tension which is acting at a particular angle, and that tension is acting at this angle. So we're going to have Ft. That is the tension. So that is the free body diagram for that object. This is the free body diagram of the object. 8 kg block, that is the free body diagram. The tension is acting in that direction where I've pointed it. Okay. So now let us check at the following question. The following question states that when the 8 kg block reaches point B, the angle between the string and the horizontal is 15, and the acceleration of the system is 1.32 meters per second. The acceleration is 1.3 meters per second. Give a reason why is the system not in equilibrium. Why is the system not in equilibrium? So the system is not in equilibrium because the net force is not equals to 0. The net force is not equals to 0 because we have an acceleration of 1.32 meters per second. So that system is not at equilibrium because the net force is not equals to 0. because there is an acceleration of 1.32 meters per second. So notice that by equilibrium means that the sum of all the forces that are acting on an object is equals to 0. Equilibrium, it means that the sum of all the forces that are acting on the system is equals to 0. So you will take note that whenever we talk about the equilibrium, we mean that the sum of the forces is equals to 0. I hope you are understanding. Okay. Let us come to the second question. It says, use the 2 kg mass to calculate the tension of the string. Use the 2 kg mass to calculate the tension of the string. Okay. Just for the sake of explaining, we can even draw the free body diagram of the 2 kg string. The 2 kg string is like this. It's in the air. So we're going to have gravitational force. Then the force which is upward is what? Is tension. It is not normal force. There is no normal force for 2 kg block. How do we know? It's because there is no surface. Normal force is a force which the surface exerts on an object it is in contact with. So when there is no surface, it means there is no normal force, because normal force is a force which is exerted by a surface. So you need to take note of that. Normal force is a force which is exerted by a surface. So if there is no surface, there is no normal force. So the only force that is going up in that one, it is only tension force for the 2 kg block. The question requires us to use what? Use the 2 kg mass to calculate the tension in the string. We need to calculate the tension in the string. They say that, let me read the question again. A block of mass 8 kg is placed on a rough horizontal surface. The 8 kg block, which is connected to a 2 kg block by means of a light inextensible string, passes over a light frictionless pulley. It starts sliding from A as shown. When block 8 kg block reaches point B, the angle between the string and the horizontal is 15. Acceleration of the system is 1.32 meters per second square. So acceleration of the system they are talking about everything. The system, they are referring to everything, they are referring to all blocks. So it means acceleration of the system, acceleration of the 8 kg and acceleration of the 2 kg they are the same. It's 1.32 meters per second square, because that is the system. System is everything. So how do we calculate the tension force? So let us check. For the 3 kg block, what is F net? For the 3 kg block, what is F net? What is F net for the 3 kg block? We can also check, can use the formula of F net. Yes, F net is equal to MA. F net is equal to MA. So F net for that one, we focus on forces that are horizontal only. Not horizontal, sorry. We focus on forces that are vertical only. What are the forces that are vertical there? It is these two forces. They are clear, right? The rotation force and the gravitational force. So it means F net is forces that are vertical only. So it means that our F net is going to be tension. Tension is going up. You can make it negative, and gravitational force is going down. You can make it positive. It's equal to MA. You can see, right? The reason we're saying F net is forces that are vertical this time around is because that 2 kg block, it is moving upwards and downward only. So we can no longer consider the forces which are sideways. As when an object is moving on a horizontal surface, we don't focus on normal force and gravitational force, because the object will be moving in this direction of horizontal, you understand? So that's why since the object is moving vertical up and down, it means with F net is the sum of all the forces that are acting vertical, you understand? So that is the difference. Okay, then tension force is what we are calculating. Gravitational force can be calculated by mg. It's just gravitational force straightforward. Then we have ma, then we substitute tension force plus mass is 2. We have 9.8 there. Mass is 8. Acceleration 1.32. Acceleration is 1.32. Then, if we want to get the tension minus tension, we just subtract these two. So we're going to have 8 multiplied by 1.32, which will give me 10.56, 10.56. Then we want to subtract this one. This is 19.6. 19.6. 19.6. We subtract it to 10. 10.56 minus 19.6. That will give me what happened? 10.56 minus 19.6. That will give me minus 9.04. It means that tension is equal to 9.04 Newton upwards. As you can see that the tension is 18 upwards. So this is the direction of the what? Of the tension. Direction of the tension and the magnitude of the tension. So now we go to the tension. Let us check the next question. The question says, calculate the kinetic frictional force between the 8 kg block and the horizontal. So now we need to calculate the kinetic frictional force between the block and the horizontal. So we can do it. We know the tension. Let us write that tension somewhere. I think we'll need to use it. 9.04 newtons. So we are noting it somewhere. Let us erase this and we deal with the question of calculating the kinetic friction. The kinetic friction. The question wants us to calculate the kinetic friction. How do we calculate the kinetic friction for that one? Calculating kinetic friction for that one, it will be much more easier. We're going to use formula that is called F9 is equal to MA. Kinetic friction, it simply means friction. Do not be confused. Kinetic friction, it simply means friction. So, what is the direction of that object, the 8 kg, the one which we are being requested to calculate its kinetic friction? It is moving horizontal. It means F net is the sum of all the forces that are acting horizontal. F net is the sum of the forces that are acting horizontal. So we are going to check that. For the 8 kg block, we even drew its free body diagram. For the 8 kg block, what are the forces that are horizontal for the 8 kg block? What are the forces that are horizontal for 8 kg block? What are those forces? So for 8 kg block, we have two forces that are horizontal. The first one is frictional force. The first one is frictional force. Then the second one is the horizontal component of that tension. The horizontal component of tension. Not tension, because tension on the 8 kg block is acting like this. Yet the surface is like this. Meaning that we won't use tension as it is. We will need to resolve it into a horizontal component. Let me make a drawing for that so that we can understand. This is the 8 kg block. Tension is like this, Ft. Tension is acting at this angle. Can you see? At this angle, 15 15 degrees. Tension is acting at 15. So it does not act horizontal since the object is moving horizontal here. So what will we do? The frictional force is the horizontal force. The x component, which is Ftx is the horizontal component of this tension force. It is the one which is acting horizontal. Understand? Okay, so let us write this one. So here we're going to have F frictional force, which is negative. It is opposing tension. We're going to have minus Ff plus Ftx is equals to Ma. And we are calculating the frictional force. The question is requesting us to calculate the frictional force. So let us deal with this one. Frictional force plus Ftx is the x component of the tension, which will be what? Ft cos theta is equals to Ma. Then can substitute now. Frictional force plus Ft will go 9,04. Then cos 15 is equals to mass is 8. Acceleration 1,32. It's 1,32. That is our acceleration. Then if we want to get the frictional force, we will just subtract 8 multiplied by 1,32, subtract it with 9,04. 8 multiplied by 1,32, you get 10,56. You subtract it with that of 9,04 multiplied by cos 9,04 multiplied by cos 15. Cos 15, and that will give me 8,73, right? Meaning that the frictional force is going to be 10,56 minus 8,73, which will give us 1,83. 1,83, meaning that frictional force is equal to 1,83 newtons to the left. So that is